Hello everyone and welcome to this video where I'm gonna demonstrate to you my final project of real-time rendering for Trinity College Dublin. So what is my project about? It is about creating a PBR shader IBL renderer. So the point was to create a program that would allow a user to load a 3D model from his file system and to visualize it here in the program, and this object would be lit by the surrounding environment map. So let me start the presentation. So the program is as shown here, where there's three panels: the scene panel, which is the OpenGL viewport panel, where we can see the scene and the object we're gonna load. The properties panel, which is the panel where we have all the properties for the object we're going to load, and the IBL panel, where we have all the IBL, which is image-based render lighting related parameters. So I'm going to demonstrate to you later. So the first thing we can do with in this application, we have the viewport here, but we want to import a 3D model in it. So we choose a model from our file system. So I'm gonna go and grab a model I already have, which is FBX, but we can also load OBJ or DAE objects. So I'm loading this file into the object, and you can see it appears here. I can zoom with my mouse, my scroll, to get closer, but I can also rotate with the right click around the object. So when we loaded this model, we can see that the name of the model appears here in the current model, and if you want we can make it rotate just to display the light around it, but I'm gonna do that. So we can see that the material menu appeared, where we have the different textures we can put on the object: albedo, normal, roughness, metallic, ambient occlusion, and height. So these are the textures and the parameters we can play with in this program. So this object already has an albedo map, as you can see here, for the color. We can load another texture. If I click here, flip the texture, or activate and deactivate it. So if I deactivate it, we can see that it disappears, and we can see clearly how the normal mapping is working. So I'm going to reactivate it, and same for the normal. So if I remove it, we can see that it loses many of its details. So if I remove the albedo, we can see that without normal mapping it's pretty flat, and if we add the normal mapping, it adds directly a lot of different details for no cost actually. So I'm going to put back the albedo, and we can also add other textures like the roughness map. So I'm going to add that right now. Textures, there's different textures files we can choose from. So it's TGA for here. So I added the roughness, and we can see that it added many small details. If I deactivate it, you can see that a lot of detail appeared here, and it's a bit more shiny because it's made of metal. We can also add a metallic map, because this is the PBR shading. So I'm adding the metallic, and we can see directly that it's even more shiny. If I click here and deactivate it, it loses a bit of its shininess in some parts. So this is the metallic. So we can see that it's with, so it's way more shinier. And finally, we can add a ambient occlusion map to the object, which will cast soft shadows on it and give it a bit more details too. So if I deactivate it, we can see directly that it has a bit of detail and shadows at some places that we want. And this is our final object with PBR shading. So it's very, very realistic, and we can see that it reflects very well the light. So we can add all of these textures to the material of the object, but also the height, but this object doesn't have a height, but we could if we want. So this is how the PBR shading works. But the good thing about this application is that it lights the object, the main object, with image-based lighting, so with the surrounding skybox. So you can see here, if I put the angle right there, you can see the reflection from the TV that is here on the object. So this is a very good feature. So the object looks like it is inside the environment and not just put inside and not lit with it. So you can see the reflection clearly, and even here we can see the reflection from this door, this window here. So this is very good, and the object looks like he is lit by the environment and he is placed in the environment. So this is how the IBL work, but I'm going to demonstrate later this panel. So concerning this panel, the last thing we can do is play with the light, because this cube is a light that I placed here. So you can see here that it's lighting the object here with a white light, but we can turn it different colors, black, red, and all the different colors if you want, a green light, purple, etc. But I'm going to turn it off for now. And we can also obviously move its position if you want. So as said, this object is lit by IBL, and in this program, in the IBL panel, we have 3 different skyboxes built in that we can play with. So this is the house one, so you can see it's lit by the surrounding light. But we also have a factory one, so you can directly see that the object is changed a lot of color because it's lit differently with the new skybox. If I use the first one, for example, we can see that the object is way clearer because there's more light in this environment than this one, which has less. And for example, we can see this bright light here. If I turn around, we can see it reflected here very well. Same for the bottom, there's a very big light here, and if I place my camera here, we can see it reflected here, so, and even below. So it's really inside the environment, is very realistic shading and lighting. Even here we can see that the roof is displayed directly on the object because it's very shiny. And I have a third one, which is the beach. So we can see here that once again the color changes because the environment changes, and how the way it is lit changes too. So the way the IBL work actually is by creating 2 pre-computed texture maps that will be used as a skybox to color light up the object with diffuse and specular lighting. So for the diffuse light, we use we pre-compute the environment map and apply a convolution on it to blur it a lot, and to have if I remove the albedo, for example, and the metallness, we can see that there's one color, main color, that appears without the specular, and this color is the diffuse one. And after the convolution, the map looks like that. If I click on irradiance, we can see how it looks like. So this is what we sample in the skybox to light the object with diffuse lighting. So it is a very important Gaussian blur, a blur of the textures, the skybox, that we sample from the direction of the normal of the object, and this is how it is lit up with diffuse lighting. For the specular one, we use the same kind of technique but blur it less and use Mip maps with the roughness levels. You will see how it works in the report, PDF report, but we use a pre-filtered version of the skybox, so like this one, and pre-filter it 5 times and put it in Mip maps. so that we can sample it from different reflection level, so for different different roughness levels. But in order to do the specular lighting, like the reflection of the specular on the object, we need to pre-compute also, and to apply a small blur to it with different roughness levels. So this is how the IBL work as a summary. And I'm going to demonstrate to you another model that I loaded. For example, this phone here, where we obviously need to load a roughness texture too. Which will be in GPG, roughness, metallic 2, and ambient occlusion. And we can see that the object is very realistic and lit up with the environment too, so we can see the reflection of the TV here. And even here at the bottom we can see the floor reflected on the object, the metallic parts especially here too. And it allows us to have very realistic objects that we can visualize. I can also demonstrate a last one, for example this statue, and we're gonna load the roughness of this statue. PNG, and the metallic of it. It doesn't have any metallic because, yeah, of course it's not a metallic object. This has ambient occlusion anyway, and we can see that it is very well lit. And if I make it turn, you can see that it's lit correctly. Here is more orange because here is more orange, but here is more purple because here is more purple in globe in general, like the irradiance is a very good example. Here it's very purple because here is very purple in the pre-computed diffuse irradiance map, while here is more orange, so here is going to be more orange too. So lastly, finally in this panel we have a height demo, because all of these PBR 3D objects don't have any height maps, but I wanted to demonstrate that my PBR shading works and that the height map, which is also called parallax mapping shading, works too. So I have 3 and 4 different objects to demonstrate from. So I'm going to stop the rotation and show you. So I have a brick wall to demonstrate the parallax mapping PBR. So we can see here that the bricks are using a height map, and it's pretty realistic. Also have the same example with wool. So we can see here that it's very realistic and it has some height to it. And finally I'm going to demonstrate you the rock formation. So this is, it has some height to it and it's very realistic too. And it's still lit up by the TV behind. And I also have the example of a muddy road. It's very bright because the TV is very bright too. But we can even see the reflection of it, and the Mip-map level of the pre-filtered specular light that I showed you earlier. We can see it clearly here reflected on the water, because this is supposed to be water. And finally with the wool, I can demonstrate to you also the IBL very well, because you can see the color of it now. If I use the factory skybox, it changes quite a lot because the environment lighted in a different way. So we can see the difference. And with the beach, it's also different from here to here. That's because the environment lighted up in a different way, and the wool reacts in a different way too. So this is it for this demonstration. Oh, and also I'm using ImGUI for the UI with the panel implementation. So this means that these panels, we can actually move them. So I can move the viewport however I want. I can resize it in every ways, and I can place it anywhere I want. So for example, if I want this panel at the top, this panel on the right, this panel on the left, I can have this this way if I want to, but it's pretty practical. So for example, if I want it that way, I can have it that way, and I can resize them pretty well too. So this is a viewport that is made with a frame buffer, and this is actually a texture that I use on it, but I find it very, very good in a way. Up. So I'm gonna put back everything how it was. Up, 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 up. So this is a really cool functionality of it too. And yeah, that is all for my final project demonstration of real-time rendering. Thank you very much for your attention, and goodbye.